My name is Kaivanto, and I'm an economist at Lancaster University, where I'm principal investigator and director of Crucial, the Climate Risk and Uncertainty Collective Intelligence Aggregation Laboratory. Together with Mark Roulston, who is director of Crucial Operations, we have established Crucial as a collaboration between Lancaster University Management School and the Land, Environment, Economics and Policy Institute of the University of Exeter to respond to the need for calibrated, high-quality climate risk forecasts. We employ expert prediction markets, hosted on the SCOR prediction market platform, to elicit, aggregate, and summarize knowledge on future climate risks, drawing on expertise from diverse disciplines in the natural and social sciences.
The Earth's climate is changing more rapidly than it has in millions of years. There's a consensus among climate scientists that this is because of increasing greenhouse gases in the atmosphere due to human activity, mainly the production of carbon dioxide from burning fossil fuels, coal, oil, and natural gas. While scientists agree the planet is warming, they agree less about how much it will warm and what the ramifications of this will be. For example, experts agree the warming will cause global sea levels to rise over the next century, but it could be by just a few centimeters or as much as 2 meters. Understanding uncertainties like this is vital if we are to adapt to our changing climate. Predicting future climate is complicated. It requires knowledge of meteorology, oceanography, and other natural sciences, and this assumes future concentrations of greenhouse gases are known. In reality, emissions of greenhouse gases must also be predicted, something that requires expertise in policy, economics, and the likely path of technological innovation. Since the 1960s, scientists have used computer models to forecast climate. At first, these forecasts were used to draw attention to the effect of pumping greenhouse gases into the atmosphere to motivate reducing these emissions. But more recently, forecasts are being used to estimate our exposure to climate-related risks and plan for how we should adapt to them. Also, while the workhorses of climate forecasting are coupled general circulation models, which simulate the dynamics of the coupled ocean-atmosphere system, new types of models, including some that use artificial intelligence, are being adopted. How we should synthesize these different modeling approaches, along with other forms of expertise, is a major challenge. While climate forecasting began in universities and government research agencies, these organizations have been joined by commercial providers. Providers of short-range weather forecasts, perhaps 1 or 2 days ahead, can demonstrate their skill in a statistically meaningful way in just a few months. But unfortunately, this isn't possible when forecasts offer years or even decades in the future. By the time a forecast user finds out whether a forecaster is any good, it'll be too late. Forecast users are faced with the task of picking a provider with no track records available to judge their quality.
The problem is complicated further by the interdependence between greenhouse gases and climate predictions. Greenhouse gases affect climate forecasts, but these forecasts are taken into consideration by politicians when creating policies to curb emissions. Joint predictions of greenhouse gases and climate are needed to give policymakers useful information about the sensitivity of climate to greenhouse gases. All these problems that climate forecasting faces can be addressed using a technology called prediction markets. Prediction markets are markets, but their purpose is not to transfer ownership of assets or of risks, but to use the proven ability of markets to discover and aggregate information from many different sources. Prediction markets use the mechanics of betting to elicit and combine knowledge from those taking part. But unlike conventional gambling, these participants are not meant to be sources of revenue, but sources of information. The Crucial initiative uses prediction markets with expert participants to generate consensus probability forecasts of climate-related risks. Crucial uses a prediction market platform that has been specifically designed for climate applications. On the platform, participants can buy and sell contracts that pay out 1 credit if an outcome covered by the contract occurs. The prevailing price of an outcome can be interpreted as the predicted probability that it will occur. The platform uses a market-making algorithm that is always willing to price and trade any combination of outcomes. This means markets with thousands of possible outcomes can be supported, so the markets can produce forecasts in the form of probability distributions for target variables such as temperature anomalies, sea level rises, or greenhouse gas concentration.
Crucial's platform has been used to run prediction markets for seasonal weather, El Niño events, hurricane activity, and crop yields. It has also been used to run markets which simultaneously predict two different things. Such markets could be used to produce joint probability forecasts of greenhouse gas concentrations and global temperature anomalies, addressing their interdependence and providing estimates of the sensitivity of the climate to greenhouse gases. The markets for climate risks that have already been run on Crucial's platform show that the collective predictions they produce are well calibrated. This means the predicted probabilities are consistent with the frequency of the actual outcomes. They also demonstrate how these collective predictions can dynamically incorporate new information as it becomes available to people taking part in the markets.
Funding from SCOR will allow the prediction horizon of Crucial markets to be extended beyond a year towards the multi-year timescales relevant for climate change. The goal is to establish expert prediction markets as an important mechanism for synthesizing, summarizing, and incentivizing research into forecasting climate-related risks. Individuals and organizations that take part in Crucial's prediction markets don't have to pay. Instead, they are given on-platform credits, but their accumulated credits can be converted to cash. So Crucial is not only a way of combining the expertise of many forecasters, but also of compensating these forecasters for the contributions they make to the accuracy of the collective predictions. Crucial has the potential to be a totally new way of managing and funding climate forecasting research, a way that is more effective at aggregating knowledge and more efficient for distributing funding.